I'm Judd. I want to talk about my new Sudoku puzzle I just created called Rain of Arrows. This is a Knight's Move Arrow Sudoku. This puzzle is interesting, or was interesting when I made it. I decided I wanted to try some Arrow Sudokus and Knight's Move together. I decided, I needed them to be, kind of close to each other because Knights don't have that great of a distance. I wanted, if you color this, I want you to be able to take that out of other cells. So I wanted to mush them all together, but my real design goal was to have 6 different arrows in a column. So I sat down at my computer, I tried, let's put in an arrow here, see what, oh, there's no solution. So well, let's put an arrow here, oh, there's no solution. So let's put an arrow here, oh, there's no solutions. So I played with it for a few minutes, and I was like, oh, I can't make this actually work. What if I just try 5 arrows? So I put these 5 arrows in, and I said, hey, are there any solutions? Well, yeah, there is. There's many solutions. So I was like, oh, let me look through the solutions. Well, I can see that this 6th cell is sometimes small enough to be on an arrow. But the combination of all these is not low enough to be an arrow. So I need somehow to jag the arrow in order for this to work. So I put this 6th arrow in, and I said, hey, are there any solutions? And the computer said, oh yeah, there's a unique solution. So after 15 minutes of fooling around just trying to come up with an idea, I already had the puzzle. And that is very unusual. I've taken years to work on puzzles in the past. So things just falling together, not how it normally works. That was about a week ago. I've spent the last week trying to decide if I want to release this puzzle, and also deciding if this puzzle is humanly solvable. And the answer is yes, it is humanly solvable. I am going to solve it now. I'm going to solve it as much for my own benefit as yours to record the solution path for how to solve this puzzle before I forget. Should I release the puzzle? That's another question I've struggled with for a week. I'm going to release the puzzle. Problem is, I don't know if I like this puzzle very much. So what's wrong with this puzzle? Well, first of all, I love the aesthetics. It looks like a very nice puzzle. I love the simplicity, the elegance of just having arrows. Normally I'm putting other things in to disambiguate, like crop key dots. So this looks like a great puzzle. The problem is, when I design a puzzle, I normally design it so you have to come up with the break-in. So there's some elegant thing you have to figure out at the beginning in order to solve the puzzle. And this puzzle doesn't have a break-in. I would describe this more like a slog. You're just going to pencil mark everything. You're going to say, can this be a 1? No, if I make this a 1, it breaks this other arrow, so take 1 out of there. And you're just going to go through and you're going to do analysis on each and every cell and decide whether or not it works until you come up with a solution. So in the puzzles I like, typically you ask a computer, hey, how do you solve this? And the puzzle uses set, so the computer says, I have no idea how you would begin this puzzle, whereas the human is able to do it. This puzzle is exactly the opposite. If you give this to a computer, it solves it in 1 second, whereas there's no elegant way for you as a human to do it. The other problem, so I'm going to try and explain this puzzle using logic, but it's going to be super difficult. Like, will you be able to see what I explain before I explain it? Probably not unless you can look 10 or 12 moves ahead. So really, I think for a human to solve this puzzle, you're going to have to use bifurcation. You're going to have to say, all right, what if I set this to 6? What happens? Does that break the puzzle in 10 moves, and you move forward, and they go, oh, that doesn't work, and then you go back. So if you're a purist and you don't like bifurcation, I don't think this is a very good puzzle. So I'm not thinking it's going to be rated as highly as some of my other puzzles. All right, with that said, let's talk about how to solve it. Well, first we're going to start in this middle box. We have 6 arrows on it. Well, you can't have a 7, 8, or a 9 on a 3-cell arrow. So obviously those have to go off of the arrow lines. So we're going to put those here, which necessarily means that these are going to be a 1, 2, 3, 4, 5, 6. The minimum, but also it is exactly what must be on all of those arrow lines. So 1 through 6 added together is 21. I have 3 extra cells that I have to add onto that 21. So if this was a 1, I'd have a sum of 22. And if this was a 1-2 pair, that's 3 more. So that's a 21 plus 1 is 22, plus 3 is 25. So the sum of these 3 arrows must be exactly 25 or higher. Now there's only 3 ways to do that. I could have a 9, 9, 7, I could have a 9, 9, 8, or I could have an 8, 8, 9. So what we just learned is all of these digits are 7, 8s, or 9s. They can't have a 6 or lower in them. Now, this is a Knight's Move puzzle, so frequently you're going to color. I'm going to color now because it will help us in a... Whoops. Didn't move fast enough. Alright, so this is not going to be a color the entire board and then put numbers in, because we're going to have to do analysis on each and every cell. So we're going to do analysis, color, do some more analysis, color, do some more analysis, color, kind of thing. But why do we need coloring now? Well, if you look at this 7, 8, or 9, it sees red and it sees pink, so this must be exactly purple. If you look at this 7, 8, or 9, it sees red by Knight's Move, and it sees pink by row, so this must be exactly purple. So what did we say? Well, this was either a 9, 9, 7, 9, 9, 8, or 8, 8, 9. So we just learned that can't be a 7. Purple's not 7. We also said if we had 9, 9, 8, that comes to 26. Our minimum was 25. So that means we can have up to 5 counting these 3 digits together. So this is going to be a 1, 2, 3 pair. Well, not pair. Not even triple. The values can be 1, 2s, or 3s, except this one can't be a 3, because that would make that a double 1. So this is either going to be a 1, 2, 1, a 1, 3, 1, or a 1, 2, 2. So we must have, if we had a 2, 3 pair here, that's already the 5, we wouldn't be able to add this digit. So we must have a 1 here. Let's mark that. And we went through our combos. We must have a 9 here. This is 9, 7, 9, 8, or this is the 9, and that's the 8. Let's go ahead and pencil mark our other arrows. So we know a little bit less about these because we don't know the sum. So those are all 3-cell arrows. So they're 6, 7, 8s, or 9s. Except for we just said there's a 9 there, so that one's not a 9. And then let's go ahead and pencil mark 1, 2, 3, 4, 5, 6 for all of those. All right, so the first question we have to ask in order to solve this is, where do all of the 1s go? So we've already learned that there is a 1 here, so that means that sees both of those cells, that sees both of those cells, so neither of these can be a 1, because through row and Knight's Move, that would remove a 1 from both of those, which is not possible. This cell has a 1 in it. Is that possible? Well, the answer is no. Well, why? Well, because we have a 6, 7, or 8 arrow here, because 9's up above it. So there must be a 1 on one of those cells. Peach sees all 3 of those. That cannot be a 1. Next question is, can I have a 1 on this arrow? The answer is no, but it's more complicated. So what are our options? Well, I could have, if I put a 1, then this becomes a 2, and then I have to get to 8 or 9. So I could have a 1, 5, 2 for an 8. That 8 makes that an 8, which makes that a 9. Now we put a 1 on here, so there can't be a 1 here. So the question is, who gets the 1? Because I have a 1 here or a 1 here, but I can't do both. Because this 1 is gone because we put the 1 up here. Well, if this is an 8, obviously this needs a 1 on it. But if this is a 9, we have a 6 in here that has to be on a line. So there has to be a 1, 2, 6, 9 line. So this must be a 6 and that must be a 1. But that is an 8 and that must be a 1. So a 1, 5 doesn't work. We can do that slower with bifurcation. 1, 5, that turns into an 8, that turns into an 8. And now this 8 actually has nowhere where a 1 can go because we put the 1 here. If I may put the 5 there and the 1 there, still, this is the 9. It must have a 6. That can't be a 1, it's a 2. So that has to be a 1, and that can't be a 1, that can't be a 1. So that has to be a 1. So that's the conflict. All right, what if I put a 1 up here and a 6? All right, well, a 1, 2, 6 makes that a 9. That makes that a 9. This is going to be a 7 or 8. Well, I have one more 1. If I put it here, can't be here, so I have one of these gets to be a 1. Obviously, that needs to go on the 7 or 8 line, so that becomes a 1. But now we need to look at this arrow. This is a 6, 7, or 8. It must have a 1 on it. If I put a 1 here, then that takes a 1 out of there, and it takes a 1 out of there, which means I put a 1 here. Okay, that looks like it works. But here's the problem. I have a 3-cell arrow right here. I've just placed a 1 in this cell. This cannot be any lower than 9 now, so that becomes a 9, which means a 9 can't appear in any of those cells. We started off with a, let's make this a 1, 2, 6. That's a 9, so that's a 9. So 9 can't be in any of those cells. So notice there's nowhere in box number 8 to place a 9. This is going to be a very common theme for solving this puzzle. Whatever goes here is going to be limited here. So this cell and that cell obviously can't be the same because it takes it out of all of those cells. So a 1, 2, 5 doesn't work. We can do that slower too. 1, 2, 6 makes that the 9, makes that the 9. This is no longer the 9, so it needs the 1, has to go there. That took 1 out of here. 1 goes here. This becomes a 2, 3, 4. That's the 9, and now that's the 9. There's nowhere to place a 9. So a 1, 5 fails. A 1, 6 fails. So there cannot be a 1 in either of those cells. And we have just learned in this box there is only one place where a 1 will go that doesn't ruin all the other arrows. That's there. We need a 1 here, can't go there anymore. It's there. We need a 1 on this line, can't go there or there. That's there. Let's clean up our pencil marks. Whoops. No ones there, no ones there. We can actually color those. Those are all going to be brown. All right, the next step we should do is some additional coloring. So I would like to ask what color this cell is. Well, it can't be green, yellow, or light blue because they're in the same column. Can't be peach or pink because of Knight's Move. Can't be red or pink because those are 7, 8, 9, and this is on an arrow. So this is either one of these two corners, or it's either brown or blue, but we just added a brown underneath it. So this must be exactly blue. There's one more cell that has exactly one color. That's this one. Can't be these three. Can't be these two by Knight's Move. Can't be 7, 8, or 9. We just added blue directly above it, so it can't be this. So peach. This is exactly peach. All right. This is the bad part of the video. Perhaps there is an easy way. Well, I don't say easy. Maybe there's another way to solve this puzzle. Maybe you can look at each of these cells and say, well, that can't be 2 because that breaks this other line. Maybe you can, do analysis on every one of these cells and start to limit what the choices are in there. That's not what I'm going to do. I'm going to do the fast, quick, dirty approach. My question is, can this be an 8? The answer is no. Well, why not? Well, it's going to take bifurcation, but I'll explain it to you. If this is an 8, then this is an 8. If those are 8s, this must be the 9. Well, we said a 9 must have a 6 on it, so that becomes the 6. I have a 6 I have to use somewhere in this box. It has to go on a 9 line, not an 8 line. So that becomes a 6, this becomes the 2. We have an 8-9 pair. So this is a 6 or a 7. It must have a 2 on it. I just made this a 2, so this must be the 2. This 2 looks back into box 5, sees these 2 squares. Those can't be 2. That's fine, because this is an 8 line. So an 8 with a 1 that doesn't have a 2 on it is a 1, 3, 4. Okay, now here's the tricky part. Let's talk about this arrow. There's a 2 here, so there's no 2 on this line. This has become a 3 or a 4, so this is a 3 or a 4. So what is this cell? It can't be a 2. It could be a 3. So I'd have a 1, 4, 3. This would sum to 8. But remember, we said, what happens if purple is 8? Well, if purple is 8, 8 can't go here. And if this is 8, 8 can't go there. So that fails. What happens if I make this a 4? Then this is a 3, and that becomes an 8. So that fails. So I need to make this higher than 8. So I'm going to take my 1, my 3 or my 4. We have to use the 3. And I'm going to put a 5 here to make this into a 9. So now 9 can't go here, so it goes here. But 8 can't go here, so it goes here. And that looks good. The problem is we have placed a 5 right here. So where does 5 go in box 7? Well, it can't go here, and it can't go here by Knight's Move, and that can't be a 5. And this is going to be a 6 or a 7. So that can't have a 5 on it. So the 5 goes in one of those 2 squares. We said that this was an 8. That is a 3, 4. What's the other 8? Well, this 8 must be a 1, 2, 5. And notice, just like we have a problem here, we have a problem here. This has a 5 on this, so 5 can't go here. There was a 5 here, so 5 can't go here. So none of these cells in box number 4 can be a 5. So for that reason, these cannot be an 8. Let's do that slower. Gonna make that an 8. Whoops. Gotta remember to change from the colors. Make that an 8, that an 8, that an 8, that becomes a 9, that becomes a 6, that becomes the 2. This needs a 2, goes there. This doesn't have a 2 or a 6 on it. Can't have a 5 on it without a 2, so that becomes a 3, 4. That becomes a 3, 4. So now I can't put a 2 here. If I put a 3 or a 4, that becomes 8. No 8's possible. So this has to become a 5. This is a 6 or a 7, so this is a 3 or a 4. We made that into a 9, so that's a 3. That's a 4. That's a 7. Now the 5 looks in here, can't go there, can't go there, can't go there. 5 goes there. This can't be have a 6 on it. We have a 3, 4 pair, so it can't be a 3, 4. This has a 5 on it, so no 5 there, no 5 there, no 5 there. And it fails. So what did we learn? Well, we took a shortcut to determine that it's not possible for these digits to be 8. Therefore, they must be 9s. So let's clean up all of our pencil marks. This is a 9, so a 9 must be here, so that can't be a 9. While we're cleaning up, this is a 6, 7, or 8, which means it can't have a 6 on it. This is a 6, 7, or 8, can't have a 6 on it. This is a 6, 7, or 8, this can't have a 6 on it. And notice this feeds back into the center. This is a blue cell that is not allowed to be 6, so blue cannot be 6. This is a peach cell, can't be 6. That can't be 6. So we're starting to limit the 6 to one of the middles. Well, we know it's not this, because this is a 7 or an 8. It has to go on one of the 9 lines, so one of those two is going to be a 6. The next question we're going to ask is, can I make this a 2? Well, that would be a 9 line without a 1 on it, because there's no 1 here. So this would be a 2, 3, 4. So this 9 must become the one with the 6. So this would be a 1, 2, 6. Here's the problem. If I put a 2 here, that is going to take 2 out of all of those cells. That's going to take 2 out of that cell. And that is going to break the puzzle. Why is that? I think we have to do it to see it, because I don't see off the top of my head why this can't be an 8. So I'm going to make that a 2. Oh, right, because this is going to become the 5 in that. Yeah, if I make this a 2, 3, 4, I have a 3, 4, 2, 6. This becomes the 5. This has to become the 2. 5 plus 1 plus 2. This becomes the 8. So this is a 6 or a 7, but by placing the 2 here, I've taken it out. I can't have a 6 or 7 that doesn't have a 2 on it. Okay. So this must be a 1. We have a 6, 7, or 8. That has to have a 1 on it. It can only go there now. We can color these. Those must be brown. Where are we now? Okay, well, notice we have a 9 where we add a 1 to it, and then we add 2 more digits to it. That's going to be a 9, 1, 3, 5, and a 9, 1, 2, 6. I can't put a 4 here because 4 plus 1 is 5, and then this would have to be another 4. So can't have 4s on a 9, 1 line, which makes this the 4. Let's clean up our pencil marks. No 4s down here. No 4 up here. All right, how are we doing? We have a 9, 9. We said it had to be a 7 or 8. That's looking good. And then this equals 5, so that's 2 or 3, 7 or 8. All of that is looking like what we were expecting. Let's ask some more questions about cells. We have to do analysis. Can this cell become a 5? The answer is no. Well, why is that? Well, 5 plus 1 is 6. This must be a 2 in order to keep this down low enough. How to make peach 5? 5. 5 plus 1 is 6. To get to a 9, I have to have a 3. So by making this 5, we've made this a 3 and that a 2. Both of those see that cell by Knight's move. That cell would have no values if I had a 2-3 pair. So those cannot be 5. What's next? Let's ask, can this digit be 5? The answer is no. I've just figured out why. If we make this a 5, plus 1, that's 6. I could add a 2 to get 8. So this would have to be a 5 and a 2. Well, this 2 takes a 2 out of there, and it takes a 2 out of there. By making this an 8, this is a 6-7 pair. 6 and 7 must have a 1 and a 2. This 5-2 removed both 2's. So that cannot be a 5. Now notice I have 2-3 pairs. So we've learned that that's a 6. So that's not a 6. So now I have a 7-8 pair. This must be a color other than peach. So that looks like it's either green or blue. Can be a 2 or a 3. This sees this cell. So this must be peach. Notice we can do sudoku now. Peach plus peach. This must be a peach. 2-3. Okay. Next question. Let's ask, can this cell be a 5? And I don't believe the answer is yes. Why is that? All right, well, it's actually very similar to the addition we were doing down here. If I make this a 5, plus 1 is 6, this can only be an 8, so that has to be a 2. This is 5, means this is 5. 5 plus 1 is 6, has to equal 9. This is 3. So we've made a 3-2 pair, which sees peach. So peach would have no values. So that cannot be a 5. So we've just learned that this is actually blue. Blues and peach are our 2-3 pairs. We have a 2-3 pair, so that's not a 2 or a 3. Can that be 5? Well, now we've got a minimum of 5 over here. Obviously, that can't be a 5. So that's a 2-3, so that's also the dark blue color. And notice we have a lot of symmetry going on here. I have a 7-8 pair with a 2-3 pair. All of those have to be different. So if that's a 7, then that becomes the 2, which forces that to be a 3 and an 8. So that would have to be a 4. Whereas if this is an 8, then this becomes the 3. Then we have a 7-2. That must be the 4. So in every case, that value is 4. We figured out a 2-3 pair, so green is not 2 or 3, and yellow is not 2 or 3. So now we have 2-3 pairs, we have 5-6 pairs, we have 7-8, we figured out the 6. We are well on our way. Oh, how about this cell? This sees blue and it sees peach. That's not a 2 or 3. This can no longer ever be a 6. We have a 7-8. So we have lots of 7-8s around. In order to move forward, I think we should do some coloring. So we can say this is a pair. Our 7 and 8s are red and pink. This is a 7/8, so it's either red or pink. But now let's ask, what else goes in row number 5? Well, we don't have a red in row number 5. So I have to put a red somewhere. I can't put a red here. Red sees this square because it's in the same box, or this cell sees this box, and it sees this. So neither one of these could be red if this is red. So red is over here, which forces that to not be red. That is pink. Let's actually put in the colors. So what are we missing here? We have red, green, blue, we have peach, we don't have yellow, we don't have pink, and we don't have light blue. Well, notice there's no pink in any of these, so pink must be here, which means pink can't be here. So that's red. That's not red, that's pink. That looks up, says that can't be pink. This yellow sees that. And I think we're done with our pencil marks. We have a triple here, so what else is left? We have blue and green, dark blue and dark green. Notice there's a dark blue here, so it can't go there. So that becomes a 2-3 light blue. I'm sorry, dark blue. That becomes a 5-6 dark green. What's next? Let's look at this cell. Can this be... Well, here's the easy way to do this. We have a 1, 2, 3, 4. So I'm left with a 5, 6, 7, 8, 9. We know 6s can't go across the bottom. We know 9s can't go here. So I have a quadruple here of 5, 6, 7, and 8. So where does pink go in here? Well, it has to go here. Where does purple go? It must go here. So we know that this is a pink purple. We also know that that means it can't have a 5 on there anymore because that's a 7, 8, 9. And then here we have 5, 6s. That's yellow and green. And we also have a 7, 8. Well, that can't be pink. It must be the other one, red. Can we clean that up at all? Yeah, yellow sees that square, so that's not yellow. And I think that's as good as we can do. All right. What's next? Let's try filling in some of these boxes. I don't have a red. I don't have a green. I do have a blue, pink. I have brown. I don't have a light blue. Notice this light blue sees that, can't be there. This green sees that, so that can't be there. So we found our red. That is a light blue, dark green combo. So this is going to be a 7 or 8. What about here? I do have red, I have green, I don't have dark blue, I have peach, I don't have yellow, I don't have pink. Alright, pink and pink see this square, so that can't be pink. Dark blue and yellow both see this square, so that's not yellow, that is our pink. That's not our pink. And then we have a yellow, dark blue combo. That becomes a 7 or an 8. All right. So let's ask the question, where does pink occur in row 8? Can't go there because there's a pink there. Can't go there because that's on a line. That sees the pink. This sees the pink. That sees the pink by knight's move. Pink goes exactly there. Alright, let's ask the next question. Where does 8 go in row 8? I'm sorry, not 8, I mean red. Red can't go here because it sees that by knight's move and column. Could go there. Can't go there because it sees a red above it. Can't go there because there's 3 reds here. If I put a red here, that would take out red from all of those squares. So there's only one place for red. It is exactly there. So that becomes a 7-8. This can't be red any longer. That is green. That becomes a 5-6. And that makes this into yellow, which is a 5 or a 6, but we see the 6. And that is everything we need to solve this puzzle, because we have just differentiated everything. By making this yellow and having it see the 6, we learn yellow is 5, we learn green is 6, which means blue is 2, for that to equal 9, peach is 3, and we just fill in pretty much everything that we have already labeled. 3 plus 4 plus 1, red becomes 8, pink becomes 7, this must be a 4, 8, 7, no 8 there, 7, blue is 6. Notice we determined through math that this was a 4, because that turned out to be a 7. 4 is light blue, which means that's not light blue, that's green, which means that's not green, that's light blue. So we have the 4, we have the 6, we have a 5, 2 pair. What do we have over here? Pink is 7, yellow is 5, and light blue is 4. And that's all. The colors have done the work for us. Figuring out that this pink makes that the one red, turns that into yellow. That's the key. It's getting this yellow here next to this 6. We can just do straight sudoku from this point forward. So I have a 1, 2, I need a 3, 5, no. Oh yeah, I'm missing 4. 3, 5, 8, and 9. That makes that the 9. I have a 5, 8 pair, so this must be the 3. What else? I have a 3, 4 missing here, so that's the 3, that's the 4. I have a 7, 8, 9. This 8 sees that, so that's a 7 or 9, so that becomes the 8. 1, 2, 3, 4. I need a 5, 6, 7, 9 here. Where else? Let's look down here. 1, 4, 5, 6, and 9. Doesn't help us very much. Where else can we look? That is useful. I have a 1, 2, 4, so that's a 3, 5, 6, 8, or 9. 3, 6, 9, 8 or 9, 6 or 9, 3 or 6. Don't know that that solved anything for us. Oh, 3's. Where does 3 go? Can't go here, here, must go exactly there. So it's there. It's there. 4's in one of those. 4's up here. 5's are not very good. Lots of 6's, however. This must be exactly 6, which I did not see down here. 6 goes up here. 7's. Not very useful. 8's. Not here, not here. That's not very helpful. I swear this is supposed to be easy at this point, because it's sudoku. What am I missing here? I'm missing a 2 and a 5. There we go. That's 2, that's a 5. That takes 5 out of here, which puts a 5 here. Still 2 places for 5. Where does 5 go? In box 9, must go exactly there. What are we missing here? I have a 1, 4, and an 8. So that must be the 8. That the 9. 6, 3, 5, 8. Puts the 3 in the corner. What am I missing here? I have a 1, I don't have a 2, or an 8. And 1 or 6, not yet determined. That becomes a 1 or a 4. It must go exactly there. Don't know about 1s, 3, 4. We don't know much. 5, we already have 6. 6 must go exactly there. 7, 8, 9. All right. Looks like we have some nasty patterns. Let's see if we can figure this out. What am I missing? 6, 7, and 9. That's not right. Oh, I have a 6 right next to them. 1, 2, 3, 4. I'm missing a 4. What's missing here? I'm missing a 1. 1, 7, 9. Alright, so that becomes the 1. That's not the 1. Alright, how do we solve this? Well, this cell right here. That sees that in the same row, that sees that in the same column, so that can't be a 7 or a 9, or it takes those out of box 2. So that becomes the 4. There, that helps. 4, 5, 9, 7, 9, 7, 5, 1. And that is how you solve Rain of Arrows. Thanks.